Hi and welcome back, and this is our next patient. This is a Samsung LED TV. Well, it's a big Samsung flat screen TV that every now and then the picture just stops but sound carries on working. Okay, now I can't show it clearly to you on camera, but when the picture goes off, if you hold a light up and look at it at the right angle, you can actually see that the picture is still there and it is still moving, which points to the backlight being faulty or something with the shutting down the backlight circuit. So let's take a look at what we're going to do. Okay, so as you can see, it is a Samsung LA40C530F1R television made in South Africa. Let's crack this thing open. A screw top. Don't want loose screws for this thing. So let's take you through a few parts of this TV now. Here is your main power supply board. It's also got control signals out to the inverters, and it's got high voltage in the inverters for the CFL tubes. Over here we've got our main board, basically, that controls every inputs and everything like that, and then it sends its signal out to the panel itself. And then under this little cover we have got the inverters. Okay, so here is all our little transformers for the inverter board. I have read on badcaps.net that it could be a CFL bulb that's failing. Don't know how I'm going to test that. Or it could be just one of the resistors or capacitors causing a signal line to go down when it shouldn't. So I need to spend a bit more time looking into this. Okay, so I've had a bit of chance now to research this, a day or two, and I've actually found a good YouTube video thanks to following from badcaps.net forums. If you look at the link in the bottom, you'll see that YouTube channel where I've learned this technique. Okay, so basically we are going to be seeing which of these 12 backlight tubes, CFLs, is drawing more current, which means it is causing a problem. Let me just show you down the bottom over here. Okay, so over here we got our backlight driving transformer for this backlight. Okay, it's got 4 pins out. Well, it's got 2 in. Let's see if we can get this right. Yeah, I'm not too sure which is which, but this is your sensing pin that goes and it feeds back to one input on this diode over here. The next transformer, also the sensing pin, pin number 4 there, feeds the other leg of the diode. So if any of these are showing greater than 0.6 volts, or depends on the threshold of the rest of the circuit. So if it's greater than 0.6 volts, say, this diode will start conducting, send the signal to the inverter power supply board, which will trigger a shutdown if it's higher than the threshold that's set through the circuitry in here. So it could be 0.6 volts, but I think it's more like 1.2 volts is the threshold. So let's start going through. As you can see, I've connected my multimeter just onto a ground point here. And you need a multimeter that's got at least 0.2 or 0.3 digits. The one I was using earlier wasn't actually giving me anything because it's doesn't have the resolution. Okay, so let's go. We have to do this while the backlight is on, or just before it cuts out, because that's when we're getting our reading. So, multimeter on AC, TV is plugged in, and if we look over here, 0.02, okay, 0.2, 0.02, 0.015, 0.024, Okay, let's carry on up. Okay, 0.025, 0.024, whoa, don't slip and short something out here. 0.021, whoa, 1.2 volts, okay, that one's definitely higher than the rest. 0.018, 0.016, well, don't slip, 0.026. So this one over here, I don't know if you can see it there, 1.2 volts, so that's definitely suspect. So let me mark that. And what we're going to do as a test, we're going to ground out that sense pin over there. Maybe I should unplug the set now. Okay, so let me zoom in. So just as the grounding out to test, I'm going to put a resistor leg just onto that pin of the transformer. Clip a crocodile lead on there, and where can I find a decent ground point on the chassis? Over there. So now plug it in. Okay, check signal cable. I'm checking the signal cable. Okay, let's go and put on a test. Yeah, let's show you static. Okay, let's go down, 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 down. We can do self-diagnosis on the TV. Okay, so here we go. Loading. Takes very long to load up a picture. Does the problem exist with this test photo? No. Okay, but that picture does look okay. If I'm looking, I don't know if you can see it on camera, it does look a bit dimmer over here. But I don't know if that's just because of that backlight number 10. I think it's number 10. Or if it's just the type of picture. Okay, so before I put it down, I ran it for about half an hour. Which actually shouldn't have been like that with this pin shunted out, but let's undo the jumper and just see what our voltage looks like now. This was 1.2 volts and it's 0.1. That is strange. Maybe it decided to fix itself, or I don't know. Well, now that I pulled off the jumper, I think I'm going to run a test for it. Maybe just run it for half an hour or so. Let me just turn that down before I get demonetized. Okay, so I think I'm going to leave it running for an hour, maybe 2 hours, and then see what happens. If it does end up dying again, I know to bridge out that transformer, and then I can even see here there is a dark spot across there, so that tube's obviously dying or dead or whatever. But let's let it run, see if it stays on for a couple of hours, and then we take it from there. Okay, so after running it for about half an hour to 45 minutes with that shunt off, basically just after I thought it had fixed itself, it stopped working again. So we are going to basically bridge out this one transformer for this one tube that we think is faulty, and then we will run it again and see what happens. Okay, now our feedback is on that last pin, and the second pin is ground. So we're looking at the pins that are in series between all the transformers, which is pins 1 and pin 3. I can either link it on the transformer, or I'm actually going to link it on the pads over here. It's pin 1 pad and pin 3 pad. And it's about 40 volts that's across those two. Hopefully I don't get too much in the shot here. So I want to avoid shorting out the ground pad. Okay, so that's pin 1 pad. I'm saying pin 1, I don't know the exact designation. Oh, the camera's going flat. And that's pin 3. Okay, so now I have bridged pin 1 and pin 3. So basically the current will go straight through this bridge and not into the transformer, which basically means this tube will be dead, but also we should not get that rising feedback voltage. Okay, so let's see. You can see a slight difference across here, where that tube is not getting any power anymore. You can, oh, it's very difficult to see actually. Okay, camera picks it up, but visually it seems okay. I'll turn that down before I get copyright strikes. So it is very visible on the camera, but it's not too visible to the naked eye. So now I'm going to leave this running for about half an hour, maybe an hour or 2 hours, and see if it stays on. If not, we have to diagnose a bit further. Okay, so if you know the show, if you know Duck Duck Goose, you'll know that we're about an hour into the show, just over an hour, and so far the backlight hasn't switched off. Whereas before it would at most last 20 minutes before switching off, and then in between about 5 or 10 times, or once every 5 or 10 minutes. So this looks like it is sorted out. So it wasn't actually anything with the firmware that needed to be updated or anything. It was merely one of the tubes that is starting to fail, one of the backlight tubes, which is drawing excess current and causing the safety to shut off. Now I can try and get another tube, but to me the picture looks reasonable, so I don't think I actually need to worry about a tube. I'll just leave it like this with that transformer bypassed, which means this tube isn't actually operating, but the picture looks good enough, so it should be fine. So now the thing is to button this thing up and then maybe mount it on the wall. We'll see. Okay, so let me switch this off. I'm happy with that. Let's close it up. Thanks for coming with me on this journey of fixing the Samsung television. Hope you enjoyed it. If you did, please give it a thumbs up. Subscribe to my channel and also click that little bell icon to be notified when we got new updates. Thank you.